Hello everybody and welcome back. We're going to continue on with the 2010 Friar contest. So let's just jump straight in and take a look at it. We're on question number 2 right now. 2A. Determine the average of the integers 71, 72, 73, 74, and 75. So these guys are nice and in order. Well, how do we determine any average? Well, we have to figure out the total sum of all the numbers we're averaging and how many numbers we're averaging. So 71 plus 72 plus 73 plus 74 plus 75. How many numbers is that? That's 5. Well, it's just a quick calculator calculation away. Or if you want to, you can go old school and do hand calculations. So on the top, we get 365. We divide that by 5. And when you know it, that happens to be the middle number, which is 73. So we get an average of 73, and that's part A. Fairly simple, just recalling the concept of averages. B. Suppose that n plus 1, n plus 2, n plus 3, n plus 4 are 5 consecutive integers. So in a multiple choice, in a multiple part question, one of the parts has been split into multiple parts. Okay. Determine a simplified expression for the sum of these 5 consecutive integers. If the average of these 5 consecutive integers is an odd integer, explain why n must be an odd integer. Okay. So first, we need a simplified expression for the sum. N plus 1, n plus 2, n plus 3, and n plus 4. Well, we don't really need the brackets there. I'm just showing you where the numbers are coming from. If we collect like terms, we have 5 n's plus 1, plus 2, plus 3, plus 4. 5n plus 10. So we have our simplified sum of those 5 numbers. And what was the other part? If the average of these 5 consecutive integers is an odd integer, explain why n must be an odd integer. Okay, well let's take a look at a formula for the average. We have a formula for the total sum. So total sum, which is 5n plus 10. We just did that, divided by 5. Well, wouldn't you know it, 5n has a factor of 5, 10 has a factor of 5. So we're left with n plus 2. So what they're asking us is, if n plus 2 is an odd integer, explain why n is an odd integer. So the number before an odd number is always an even number. So if n plus 2 is odd, then n plus 1 is even. If we go one step further, so if we have an odd number for our average, then our n value also had to be odd. Fairly straightforward. If 2 numbers differ by an even number, then they're either both odd or both even. Okay. So that was B part. Let's take a look at C. 6 consecutive integers can be represented by n plus 1, n plus 2, n plus 3, n plus 4, and n plus 5, where n is an integer. Okay. Explain why the average of 6 consecutive integers is never an integer. Okay. Well, what is an average? Well, we need the total sum. Total sum over the number of numbers. Well, that's going to be n plus 1, n plus 2, n plus 3, n plus 4, and finally n plus 5. But rather than have 5 numbers, which we did in parts A and B, we now have 6. So that's going to be, we have 6 n's, we can group all those together, and then we have 1 plus 2 plus 3 plus 4 plus 5, that's going to be 15 over 6. And so the 6's cancel out, we get an n plus 15 over 6, which is n plus, each of these has a common factor of 3, so we have 5 halves. Or really we could say n plus 2 plus a half. So we just explain why this number can't be an integer. Now we didn't have any specified n to worry about. This is the general expression for the average of these numbers. So since n was arbitrary, it didn't matter what n was. We see that our average can never be an integer. So we got a formula for the average in terms of n. We explained exactly why that can't be an integer. So that solves the question. Explain why the average of 6 consecutive integers is never an integer. There we go. So that concludes question number 2. So we're at the halfway point. We can take a breath, but don't pause for too long, and join me in the next video for question number 3 on the 2010 Fryer.